Today we will be talking about skydiving and how the weight and the surface area change how one will fall through the air. We will also discuss whether a child or an adult will fall faster. Our hypotheses include objects with a larger surface area will have a lower terminal velocity, and that an adult will fall faster than a kid skydiver. Just some definitions here. Drag is the resistance of an object in a fluid, such as air or water. It's associated with surface area, and terminal velocity, which is the greatest velocity that can be obtained by an object as it falls through a certain fluid.
So a couple of equations to keep in mind. The first equation shows that the drag force minus the gravitational force is equal to the total force on the object. Then the next equation is terminal velocity, and then the equation after that is the drag equation.
Here we have a diagram to show how the surface area is going to change with the position of a skydiver to the wind flow. For example, if it is in a vertical position, the drag force will be slower as the surface area will be less than in a horizontal position. Another option that skydivers commonly use is a parachute to increase the surface area and reduce the terminal velocity so that when the time of landing comes up, they can make a smoother descent. Here we have a table to show how the force or pressure drag depends on the shape of the object. The general size and shape of the body are the most important factors in form drag. Bodies with a larger presented cross-section will have a higher drag than thinner and streamlined bodies.
So we did calculations based on two examples here. The first of these is a long cylinder compared with a short cylinder. So we chose arbitrary values for the mass of it, the area, and we got the drag coefficients from the table shown before. So what these calculations showed was that the short cylinder had a greater terminal velocity than the long cylinder due to its greater drag coefficient. Then the next example that we used was an adult versus a kid skydiver. So we chose values for the mass based on average values for your average adult male and your average kid. And then we chose the area based on a website that we used to calculate the average area of an adult and of a kid. And then we used 1 as a drag coefficient for each. And what this showed was that the adult would reach a higher terminal velocity than the kid. So in conclusion, a larger surface area creates a greater drag, which leads to a lesser terminal velocity. The adult has a higher terminal velocity than the kid when skydiving, and it also shows that both of our hypotheses were right.
Thank you.